All right, hello, my friends. Today we'll be solving LeetCode 141 linked list cycle. And the main objective of this problem is to return a Boolean whether there is a cycle in our linked list. So we return true if there's a cycle and false otherwise. So in this example here, this linked list clearly has a cycle going from -4 back to 2. And to tell if there's a cycle, we're going to use two pointers. One will be called slow, and we'll call it S for now, for slow. And fast stands for fast, or F stands for fast. And the idea is slow will move up one node at a time, and fast will move up at twice the speed, so 2 nodes at a time. And if they ever were to equal each other, then we would return true because there's a cycle. So let's simulate this. So in the first iteration, slow would move up to the 2, fast would move up to the 0. The second iteration, slow would move up to the 0, and fast would wrap around to the 2, so it would go -4 and 2. Next, slow moves up one position to -4, and fast moves up 2 positions, so it goes to the 0, then -4. All right, and they both equal each other, so that tells us there's a cycle in this linked list, and we return true. And you might be wondering, why does this make sense? How does that even work? And I'm going to quickly explain it to you right here. We can think about the cycle as a big loop, right? Because that's essentially what it is. And we could model this as something that everyone can relate to. Everyone knows what a track is, right? So let's say you're racing somebody and you guys are both starting at the start line. So fast and slow. No matter how big the track is, if fast is moving at twice the speed as slow, then what eventually happens? Fast will loop slow. They'll eventually be on the same position, but fast just iterated all the way around and looped. And if you get lapped, then that means there's a cycle, right? Otherwise, if it's impossible to lap fast to lap slow, then there is no cycle. And let's quickly simulate this. So by the time slow reaches halfway through the loop, fast will have completed a full loop and be right here. When slow reaches 75%, fast would have reached 150%. It would have looped one full time and did another half. And when slow finally reaches its first loop, so it gets to the starting position again, fast would have looped 2 whole times and equal each other. So therefore, there's the loop, because they both equal each other here. Fast is going 2 times around the track, so 200%, and slow is went 1 time around the track, so 100%, and there's a loop. So hopefully that makes sense. So let's go into the next part. We're going to be iterating through this linked list with a while loop, and we need to know what should be our stop condition. Because we're going to be assigning fast 2 spaces ahead. We need to ensure that there's a valid reference 2 spaces ahead. And what we're going to do is say if fast and fast.next. And to show this example, let's pretend this is not a linked list with a cycle and this points to null. We need to check if fast and fast.next. So let's say fast was at the 0. We say, hey, is fast a valid node? It is. And is fast.next a valid node? It also is. So that means the worst case scenario is fast.next.next equals null, and we could assign it there. And then the next iteration, when fast is at the null, we say, is fast a valid node? It's not, so we immediately exit the loop. So this always ensures that there's a valid reference 2 spaces ahead. And if that doesn't make sense, just quickly rewind the video, because it's very important to the algorithm. So now that you understand what we're doing, let's get into how we bring it to life in code. The first thing I like to do is think about the edge cases. So let's say they gave us a linked list with either 1 or 0 nodes. So let's say they gave us a linked list that looks something like this. We can say, hey, if not head.next, so that means there is no next node after this node, then just return false, because you can't have a cycle. Cycles go on forever, right? And if the head node doesn't have a next pointer, then it can't be a cycle. And the next edge case is if they gave us a linked list with no nodes. There can't be a cycle if there's no nodes at all, right? So that's what we need to take care of first. So if not head or not head.next, what do we want to do? We want to return false. All right, so our edge cases are taken care of. Now let's get into creating our pointers. So slow will equal head, and fast will also equal head because they start at the same position. And we're going to use this while loop to iterate through the linked list. So while fast is still a valid reference, and fast dot next is still a valid reference. We can continue. And here's where we move both our pointers up. So we'd say slow equals slow dot next, and fast equals fast dot next dot next. And here's where we check if they ever equal each other. So if slow equals fast, what do we need to do? We need to return true because there is a cycle. And if it gets out of this while loop without hitting any of these conditions or the condition on line 21, we need to return false because there is no cycle. So return false. And let's run it and see how it goes. And there we go. We solved the problem and it's pretty efficient. So if you learned something new, please drop a like and enjoy the rest of your day.